Afternoon, Dr. Heenan. I guess I ended up getting a 60 out of 75 on this exam. And looking back over some of my mistakes, I've made some pretty dumb mistakes. Probably could have done a little bit better. But for question number one, I made the mistake of choosing an hour that started on the hour. So I used the time from 5 o'clock to 6 o'clock p.m. instead of just picking four consecutive 15-minute intervals. So when I went back and redid that, I ended up finding it was from 4:15 to 5:15 was the peak hour. And after using the equation, PHF equals V over V sub 15 times 4, I ended up getting a new peak hour factor of 0.939. So that was just a dumb mistake of not really knowing how to find that peak hour. You probably could have figured that one out. And then for question number two, I made some pretty dumb mistakes on that one as well. This one was frustrating looking back at my work. But to do this one, to find the total delay time, you're going to set your arrival, the integral of the arrival equation equal to the integral of the departure equation. And then you're going to add on the original Q, which was in this problem 33 vehicles. So after doing that, I find that my A of t equation is 33 plus 1.2t minus 0.175 t squared. And then you can find t to equal 17.58 minutes. This part on the test ended up getting around 47 minutes. And the problem with what I did is I misread the problem statement, and from the departure equation, instead of using 3 plus 0.3t as the equation, I used 3 plus 0.03t, and that was just a mistake of kind of going too fast and missing a zero. So that really threw off all my numbers for really the whole problem. But anyway, even on part two, I still made a mistake. So even if I had gotten that time, it wouldn't have really made too big of a difference. To find the total vehicle delay, you're going to take that integral of A of t from 0 to 17.58, the time it takes to clear the Q. Then after taking that integral, you find that the Q, or the total vehicle delay, was 448 vehicles per minute. And then finally, to find the max Q length, we first have to find where the max Q takes place at what time. So to do that, I took a derivative this time of the A of t equation, and you get that to be 1.2 minus 0.35t, and then set that equal to 0 and solve for t, and t ends up being 3.429 minutes. And then once you have that time, you can just throw that back into the A of t equation to get 35.06 vehicles as the longest queue. And then from there, you're going to make the arrival and departure curve. And this one was pretty straightforward. I made the curve and the graph correct, I believe, on the exam. But since my numbers and equations were wrong due to that misreading at the beginning, some of the numbers were just off. But you can see from my work that the area inside the curves is going to be your total vehicle delay. Your arrival curve is the curve on top, and your departure curve is the curve starting from 0 on the bottom. Where the lines intersect at 17.58 minutes is the point of dissipation. And then the longest Q is going to be located at 3.429 minutes on the x-axis. And you find that 35.06 by taking the difference between the point on the arrival curve minus the point on the departure curve, which was 35.06. So really it just comes down to going a little bit slower, reading reading the problem correctly and taking the right integrals, and I could have probably gotten 30 out of 30 on that problem. And then for the first problem, again, just not knowing where I could take my time intervals from really set me back there. And then for problem number 3, I ended up getting 30 out of 30 on that one. So I felt comfortable with all the content on this test. I just made some dumb mistakes and probably could have done better, but I think I'll do better on the final. So I appreciate it, and you have a great rest of the day. Thank you.